Hi guys, Ashwin here, and from today we are going to start a series on, specifically on Sui ecosystem and how Move is very good in Sui, and then we will be starting to look into Rust in the upcoming days because, as we already know, Rust is a very good language to be very honest, and even though it seems very tough, but it's a very good language. So we'll be start looking into Rust and some protocols, some native protocols like Walrus, Seal, and Nautilus, and we have Deep Book, which is a liquidity layer on Sui, and storage layer Walrus, and off-chain computation layer we can say Nautilus, and Seal as an encryption layer. So yeah, we'll be looking more technically and not some just document yapping things. As previously I was posting about Sui's consensus as blogs, when we take a deep look into Move contracts, you'll understand why Sui's latency is very less and their speed is absolute beast. Because there is two ways, right? We already know about it. If you didn't take a look into the blog, you can take a look where they talk about owned objects, shared objects, how Move specifically powers the consensus in their Sui ecosystem, which is Mysticeti. Yeah, I'll be taking a deep look into this in the upcoming days. Yeah, this is the intro to the series, and yeah, let's get started. In the first episode, we will start to look into how an EVM developer can easily transition to Sui ecosystem because it's pretty much very important. Lots of majority guys in Web3 are mostly inclined towards EVM, and including me. And it's been 1 year. I've been transitioned to Sui and working on EVM as well. Yeah, that's it's very good to work on Sui, and I'll tell you the pros and cons of Sui and EVM. Yeah, we'll start to discuss into that. Uh, First of all, we will be discussing about object-centric approach and how it differs between address-based approach of how we work on EVM, right? That is one thing, and then we will look into specific concepts of Move and some patterns. Like today, we will be looking into one-time witness pattern, which is very important on when we write some token modules for some protocol. Yeah, that is something we will discuss, and then we will look into, yeah, we will code along the token module, and we will see when we need upgradability in the contract, and do we have a upgradability feature. We have proxy contracts in Ethereum. Do we have something like that in Sui? We'll look into it, and yeah, let's get going on the way. Let's get started with object-centric approach and address-based approach, how it works, and yeah, let's get in. So let's take up an example. Say I'm going to purchase some 1000 USDC in Ethereum and 1000 USDC in Sui. How it's going to work internally? Let's see that first. Okay, so let's me draw a line, and yeah, let me assume this is the Ethereum side, and sorry, yeah, this is the Ethereum side, and let me have some background here, and let's say I'm going to purchase 1000 USDC contract, and how it's going to happen internally, as we developers might already know, it's going to be mapped, right? There's a mapping, say address to the event 256 something, and what is the structure? So 0x123 is my address range, and how much tokens I have, that is the mapping here happens internally. So this is the occurrence happens when we look into Ethereum based address based approach. So let's take a look similar approach in Sui, and we change the color. Sorry. Yeah, so let's take a look into this. let me say I'm going to purchase again another USDC, 10,000 USDC here. How it's going to look here? It's going to look a bit weird, but and I'm going to purchase the coin type USDC, right? And what is the difference here is we are not going to do some internal object mapping or nothing like that. We are going to transfer a whole resource. So USDC contract is going to transfer the whole coin object to me. How it's going to look? So let's say I'm going to purchase 10,000 USDC from USDC contract. It mints or transfers 10,000 worth of object to me. Okay, so let's say there is some changes as well. Transfer, and I'm going to send the coin USDC to the recipient, me. So we can find some difference here. There is no need of having some amount here. So if you take a look into EVM, we mentioned how much amount we will be sharing the USDC token to the user end, but here we are not mentioning any amount here, but we can do that. But I am just mentioning here for this point of view. Why I am mentioning we are not mentioning we are not having any amount is, let's say okay, this is an object. Let's say this is an object, okay, and this is my USDC contract, sorry, USDC token, or in Sui point of view we can say USDC coin. Okay, I want to share this to me, that is 0x1A2C something address. Okay, some account I'm going to transfer this one single object's value is around 10,000 USDC, which is very good, which is very big, and I just need, for instance, I just need 5,000. Okay, I need just 5,000 USDC. How it's going to happen here. Now there is some operations here. Split, join, and merge. These are the operations that will be happening internally for the kind of operation that I'm going to do. So let me say I'm going to ask 5,000 USDC, but in the contract there is a single object which is worth of 10,000 USDC. How it's going to handle? It's going to make a split operation, and after you split an object, say I'm going to split this object into two, you get 5,000 USDC here and another 5,000 USDC here, and I'm going to give the splitted object of this 5,000 USDC to myself. Okay, so this is the process happens. So let's say there is two objects in the contract. For instance, I am user 2 makes a transfer of 2,000 USDC, and there is a 1,000 USDC, two objects inside the contract. How it's going to happen? Now it's going to merge, or we can say it's going to join the two objects. It's going to join the two objects. It's going to join the two objects, and it's going to return me as a single object. So join function makes sure that we join two objects only, and split makes sure that we split a single object into two. And merge function, what merge function does is I'll give you an example. Say there are multiple division of USDC objects internally in the contract, and I need 3000 USDC, and there is 1000 USDC as three different objects. Then what happens is there's going to be a merge operation happens internally. So let me just show you that. Okay, I'll just write somewhere here coin merge, and let's use something like a macro, and have the coin 1, coin 2, coin 3. So this is something happens inside the contract when we try to merge three different coins and send it as a single one. Okay, so this is the difference between EVM approach and that is address based approach and object centric approach. So every single data structure is an object here. So but there are some structs that aren't objects. We will get to that in the next section. Yeah, if I missed something else in this section, I will cover that up in the next section. Yeah. Now let's start with how actually Sui acts as the coordination layer. By just going through some Sui scan or Walrus scan. I'm going to give you an example on Walrus side because currently I'm just going to give you an overview, just a little taste of it, how Sui mainly acts as the coordination layer, right? So let me switch my screen to the terminal. I'll let you know why in a second. Yeah, okay, so this is my terminal, and what I did is I have already installed the Walrus binary, and Walrus binary under the hood makes calls to multiple contracts. So here contracts are objects, like contracts are linked to objects, so you can assume every contracts are objects as well. So let me say I'm going to just copy the system object. Because Walrus makes a calls to move contract which is living on chain on Sui blockchain. So it's making an attestation to Sui saying that I am reserving some space for the blob that came in, and reserving space for what? Reserving space in the sense for the storage nodes that lives internally in the network. Okay, so if a blob comes in and blob comes into the network, the storage nodes reserve some space for the blob and stores the blob in the storage nodes. That's what this reserve space does. So reserve space says each storage nodes stores some amount of data. So why some amount of data? We can get more technically in depth. So how Walrus makes stores the data is it encodes the data into slivers and stores into multiple storage nodes. That's what happens. So let me show you how it actually reserves space. I'll just switch my screen up. Okay, so let me go to Walrus mainnet. Sorry, Sui scan. I'll go to Sui scan because it's a contract, so there's no use for Walrus right now. So what happens is Walrus says that I am attesting a blob that is stored in Walrus. I am reserving some space. I am making an attestation on chain, and as well as I am making a certification from the storage nodes, and I am saying that I am certifying this blob and storing it on chain. That's what happens here. Okay, just copy pasted the system object from the terminal. That is under the hood. Walrus makes some calls to the system objects. So in Sui we call system objects which is owned by Sui, to be very specific, and they are very much, as you can see, this is the system object, so you can say it is a system contract, and under the hood it makes for every single blob that is being stored in Walrus there are two calls. One is reserve space and another one is certify blob. So let me show you this exact digest, which is the transaction hash, and this is the recent blob got created in Walrus. single blob. So every blob in in Sui, which is NFT, which is an NFT, and it's temporary because we have a concept of epoch in Sui. So it is, for instance, if I keep epoch as one, I'm not sure previously in testnet it was for one epoch it's around 2 days in testnet. So in mainnet one epoch is 2 weeks. So if I say I'm going to store my Aadhaar in Walrus, um, I'm saving it for 2 epoch, so then it is 2 weeks mainnet. I guess it's 2 weeks right now. So let me show you in the Walrus scan. So as I said, certified blob and reserve space. Let me explain what is a certified blob and reserve space. What calls does it make and why it makes. So reserve space, I'll just give you a scenario. Say I'm going to store some data into Walrus. The data comes into the Walrus, and it makes calls to the storage nodes, and that storage node says I'm going to before the storage happens, it encodes the data as slivers, and each single sliver part of the data is getting stored into the storage nodes, and that certification, not certification to be exact, the storage node tells that I'm reserving some space for the sliver, and this is the attestation related to it, some metadata about whatever is getting stored in the storage nodes. That is first thing. And then later on, after every storage nodes stores some certain percentage of slivers, because after you store some certain percentage of slivers, even though if it isn't 100%, you can retrieve the data. That is the claim the Sui team keeps. So every certification is gathered from every storage nodes, and that certifications is this exact single operation, which is certified blob. And yeah, let me show you the blob here. Okay, so size 671 MB, and the start epoch 12, end epoch 20, and as you can see, with this exact single blob ID, I can retrieve this data to my local system. So how it happens is, we have the Walrus binary, and we make call to the Walrus storage network, and it retrieves the data as my exact local system acts as an aggregator. So to be very specific, there are aggregators outside, but I make calls to the aggregator, and the aggregator makes calls to the storage nodes, retrieves the data, and give it back to me. So this is where seal comes in. So let's say I'm going to make a decentralized KYC DID platform. I need to store the other data or any other data in the Walrus to be very secure. It shouldn't be something open to all. So what I do is, I will say seal, store my data as an encrypted fashion, and make sure it is secure. So even though if you try to retrieve the data using the blob ID of my exact of my exact Aadhaar blob ID, you can retrieve in encrypted fashion, which you can't decrypt. Only it can be decrypted from me via seal encryption layer. So seal is currently in testnet, and they are launching it in, as of September 1, they are going to launch it in this month probably. So yeah, this is about Walrus and seal, how it works together, and how Sui is coming into picture. Actually, how Sui makes calls to seal is something very interesting. So very particular wallets only can make calls to seal and decrypt the blob that you stored. That's something interesting, and made an SDK with regards to seal, and it is in testnet. If you are interested, you can take a look into it. Yeah, this is all about in this section.